Hey everyone, today we'll be solving the question find the number of ways to place two people that came in LeetCode Biweekly contest 123, and this is the last one of hard difficulty. In this question you are given a points array that is having the XY coordinates and there would be n points, and the right direction of the x-axis is the positive one and the left is the negative one, and same for the y-axis that the upper one is a positive one and the lower one is the negative one. And you have to place n people including Sisaster and Takina at this point so that exactly one person at every point. Sisaster want to be alone with Takina, so Sisaster will build a rectangular fence. Like if it is building a rectangular fence, then Sisaster would be at the upper left of the rectangle and Takina would be at the lower right corner. And there would be no other point between, like inside the fence, even at the fence. The other point should be outside the fence. So we have to find how many pairs are there so that all the other points should be outside this fence. So you are given with constraints n as 1000, so you can definitely run a in square loop. So let me show the institution. In the question, you will be given with n points, that is representing an xy coordinate. Now, how could you find the number of pairs so that there is no point? Let's say there is Sisaster and there is Takina, and there should be no point even on the fence or inside the fence. So it's not a valid fence. So there would be a fence. So other points are outside over here, and Sisaster could be here, and Takina would be at the lower corner, lower right. Now, how could we find that? Let me sort the array first on the basis of x-axis in the increasing order and y-axis in the decreasing order. X-axis on the increasing order. So let's take an example from the question itself. There is 6 2 4 4 and 2 6. After sorting, what we will get is 2 6 4 4 6 2. Now I'll be running a loop, not one, it would be a nested loop. Now for I, I'm standing over here, and for j, I'll be from I plus 1 to n. Now, will this be a valid fence? Let's say 2 6 and 4 4 4 4. I know that x for j will definitely be greater than x for I. Now I have to check, is the y for j is lesser than y for I, because I'm assuming that the I index is Sisaster and the j index is Takina. Now if the yth index is lesser, then only it would be at the right corner, because I know that x for Sisaster is somewhere lesser than x for Takina. Now how could I find, like, the j for the Takina should be lesser than the y for the Sisaster? So this is one of the valid, but how could I find there should be no points lesser than Sisaster and greater than Takina? So if I use a set to store those y indices, let's say I'm over here and I'll be storing that 4. Let's say 2 6 and 4 4. For that the set is clear, so I don't have anything to find. But even if the 4 is lesser than the Sisaster, then I'll store this in a set. Now set is containing 4. As it is less than Sisaster, now I'll be moving to 6 2. That is 6 2 over here. Now I'll be checking, is there any point greater than 2 in our set? If it is, then it would be a non-valid point. Now I have one index as 4. As I am over here, like the Sisaster is now fixed, I'm traversing for all the Takina greater than x coordinate than Sisaster. So if I store all the lesser index than, like, lesser y coordinates that the Sisaster have, let's say I've stored the coordinate over here, over here, over here. Now whatever coordinate Takina has should have a yt above all them. So I'm checking, is there any y coordinate greater than me? Because I have a set which are storing all the y coordinates lesser than Sisaster. If the set has that, it means they are coming in between Sisasto and Takina. So that's the intuition. Like I'll be storing in a set that this is the Sisasto's y coordinate, and that would be the Takina's y coordinate, and there should be no y coordinate of any other point. As I have shorted this in a form of increasing x coordinate, so for sure I'll be having that x coordinate over here. So they are coming in between Sisasto's x coordinate and Takina's x coordinate. So that is for sure. Now, if they are coming between the y coordinate also, then it would be a non-valid fence. So that's what I'm checking. So let me show the code and it will be more clear. What I have done in this code is first I've taken n as the point size, then I've shorted the points in the x as increasing order and y as decreasing order using the comparator. Now I'm traversing through the points. I is representing Sisasto and J is representing Takina, and it is sorted in the increasing x coordinate. So the Takina's x coordinate will definitely be lesser than or equals to Takina's x coordinate. Now I have to check for the y coordinate. Now Takina's y coordinate should be lesser than equals to the Sisasto's y coordinate. That I'm checking over here. If it is, then I'm checking is there any coordinate that is lesser than Sisasto and greater than Takina. Then I cannot add this pair to my answer. If it is not, then I'll be incrementing my answer and I'll be inserting that current coordinate to the set again. But how I'm checking using only one lower bound? If the current jth point is less than equals to this is Astro's yth index, yth coordinate, then only I'm inserting. It means whatever coordinate y coordinate is present in the set, all are lesser y coordinate than this Astro. That's why I'm checking that if there are any y coordinate that is greater than Takina's y coordinate, it means it's a non-valid fence because all the y coordinate that are present in the set is lesser than Sisastro's y coordinate, lesser than or equals to we can say. And if there any coordinate that is greater than or equals to Takina's y coordinate, then I could not add this pair in my answer, else I'll be adding that. And after that, I have just returned my answer. So that's it. I hope you like it. Thank you for watching.